Hello everyone, and today we're going to be looking at solving equations that have exponential variables in the exponents or logs. So hopefully we have figured out that by this time log base 5 of z equals x, we can make it into convert it into an exponential function by having this as our base, 5 to the x equals z. If that can make sense, today should go well. If that does not make sense, well, come see me then. So, first one, we're going to do about every other one and have you guys do some on your own, and we'll do some in class. So, base 5, log is the exponent, so 5 squared equals x, and therefore x equals 25. Remember that if we have no base, it's really a 10 right there. So 10 to the negative 3 equals x. Remember that the negative exponent brings it down, 1 over 10 cubed, and 10 cubed is 1 over 1,000. Yes, you could have also written it like 0.001. I understand that. I like writing fractions, so that's what you get. What about c? Well, let's convert it. b raised to the negative second equals 1/3. Well, if we make this negative second go to the denominator, 1 over b squared equals 1/3. All we're doing is we need b squared to equal 3. The numerators are the same, so we're good with that. So b squared equals 3, and then b is equal to square root of 3. And one thing, we usually have plus or minus here. Let's remember here from the lesson yesterday that the logarithm looks like this. And that the domain of a log, any domain of a log, is 0 to infinity. Therefore, we cannot have a b be negative because the domain is 0 to infinity. So just as a reminder on that the domain for a logarithm is always 0 to infinity, is never any negative numbers. So when we get to d, one of the things you see is we have the addition, and from last class you know that the product rule, we can rewrite this as log base 6 of 12 times x equaling 3. And now we'll convert just like we have been. 6 to the third equals 12x. Well, 6 to the third is 216 equals 12x, and divide by 12. And x is going to equal 18. So let's look at E, F, and G. I would like you guys to try E and F together or on your own, and then we'll come back and we'll finish G. So pause it please and try E and F on your own. So please check your answers. You should have gotten 6, 25 for F, and 3 for E. So looking at this last one here, the only difference is very much like D that we did here. You should see the addition sign, which means multiplication. So log of x times x minus 3 equals 1. The only thing that you might not have seen, even though we've talked about a lot, is a base 10 there. So we're going to rewrite it as 10 to the first equals x squared minus 3x. Yes, you do need to distribute here. Subtract the 10 over, you're going to get 0 equals x squared minus 3x minus 10. And then you got a factor. Factors of 10 and subtract to give you negative 3. Well, we know that's x minus 5 and x plus 2 equals 0. And then you're going to get x equals 5 and x equals negative 2. And you would think we are done, but we're not. Okay? We have the domain here for a reason. You need to remember that. The domain, x's can never be negative, and so therefore we have to reject this one and only work with x equals 5 as the answer. Okay? And you can always check that in your calculator. You know there's a log button, and you could actually test negative 2 and test 5 and make sure you got the right answer. So that was case 1 with solving a logarithm on only one side. There you have to convert. Case 2 I think is actually easier personally. Is that if you have log A equals log B, you realize that the logs are there. That if log A equals log B, then A just has to equal B. And so therefore, I think this case 2 is actually, this page is actually easier to solve. Because look at here. We have addition, which means we have the product rule. And so therefore, log base 10 of 1,000 times 100 equals log base 10 of n. Well, notice we have log base 10, log base 10. All you are going to do is rewrite it with 1,000 times 100 to equal n. The insides have to be this equal, just as a equals b, since the log base 10s are the same. And there's only one of them. That's key, that there's only one here. Okay, so since that's the case, we know that n equals 100,000. I'm going to go do C, and then I want you to try B and E, please. So, here's C. Log base 5 of x plus log base 5 of x minus 4. We see the addition. We know that we are multiplying. So, log base of x times x minus 4 equals log base 5 of 5. Here, we know that this is x squared times minus 5x. We know that we have log 5 equal log 5. So, therefore, we are just going to set what is inside equal to each other. Inside, inside. And so therefore we're going to get x squared minus 5x equals 5. Sorry, that's a 4 though. That would help. That's a 4. That would have made my life a little easier thinking of that. There we go, 4. So we're going to get x squared minus 4x minus 5 equals 0. We just subtract the 5 over. And again, we're going to get x minus 5. X plus 1 equals 0. And then we're going to get x equals 5 and x equals negative 1. Plug back negative 1 back in. You'll notice that you have negative 1 there and negative 5 there. That's a double whammy of two negatives, and so therefore we are going to reject this. And x equals 5 is our only answer. So what I would like you guys to do is please try B, right here, B and E. So pause it and try B and E, please. Hopefully you guys got B to be 4, x equals 4, and E, you may have had a little bit of difficulty because you forgot that the power rule to 2 is brought up as x squared. So you should have had x squared equals 2x plus 24, subtract everything over, and you're rejecting, okay, x equals negative 4. Pause it if you need to look at it, pause it to make corrections. We're going to move on to D and F right here. If we look at D, we notice that we have subtraction, which means division. And so we're going to have log of x plus 3 divided by x equals log of 4. Once again, we have two logs here, one on each side, therefore we can set the insides equal to each other. X plus 3 over x equals 4 divided by 1. If you need that divided by 1, it can make it easier to cross multiply. You should get x plus 3 equals 4x. And subtract the x over, you get 3 equals 3x, and so x is going to equal 1. With F, notice that we have the power rule again. That power rule that 2 gets brought up. The reason why I wanted to make sure to do this one is that the 2 is squaring the 3x. So it should really look like this. And with addition, you know you're multiplying. So we're multiplying by 0.1. So we have log of that equaling log of 10. How did I get 10? 5 times 2. Let's multiply. So with this, 3x quantity squared is 9x squared times 0.1 equals 10. Again, the inside, we had one log on each side. The insides we said equal. If we divide by 0.1 or a tenth, we also know that that's the same as saying multiplying by 10. So we're going to get 9x squared to equal 100. Divide by 9. We're going to get x squared to equal 100 over 9, and then we will square root both sides to get x equal 10 over 3. And again, we do not worry about the negative portions because you cannot have a negative log. So you should have 10/3 there. So key points on this entire page is combine the logs using the product or quotient rules, adding or subtracting, knowing what those mean in logs. Make sure you have the power rule, and make sure that you're rejecting any negative x values that you get, as long, the key here is as long as when you plug back into the x value, you get a negative log. Let's move on to the final page. The final case that we're going to do is looking at solving exponential equations. And solving exponential equations is what I think is the most important use for logs, but that's just my opinion. We're going to look here using the method that we already know how to solve, using 4 to the x equals 8. And we know that this is 2 squared raised to the x equals 2 cubed. We know when you have an exponent raised to an exponent, we can rewrite it as 2 to the 2x equals 2 cubed. And because the bases are the same, just as we talked about in case 2, when the bases are the same, we can set the exponents equal to each other. And we're going to get x to equal 3 over 2, or how many of you like it, 1.5. Now the logarithmic approach works in what I would always do first, because we can't always think that we're going to get common bases unless it's made so you can do that. So we can use the logarithm. Notice that the x is in the exponent, and that's what logs use. And so therefore we can state if we log, quote, if we take the logarithm of both sides, log of 4x equals log of 8. Taking the logarithm of both sides. So this should say 4 to the x, so let's try that again. With the power rule states that that is in the exponent and therefore can be brought out in front. X times the logarithm of 4 equals the logarithm of 8. And notice that the x is now on the outside. We can just divide by log 4. And we can finish it as x equals, let's try this again, x equals log of 8 divided by log of 4. And if that makes sense to you, that you can do that using the power rule, then this entire page should work out for you. If you plug that into your calculator, log of 8 divided by log of 4, you will get 1.5 in the calculator. So let's look at this. 5 to the x equals 18, the same idea. Notice that we cannot get common bases, so therefore we have to take the logarithm of both sides. So log of 5 to the x equals log of 18. Power rule states that can come out in front. We get x log of 5 equals log of 18. And we're going to get x to equal log of 18 divided by log of 5. And it does say here round to the answers to the nearest hundredth, and so you would put this in the calculator. If it said to leave an exact value, you would not. Okay, so please make sure you realize that. If it says to leave an exact value, you leave it as log of 18 over log of 5. What I would like you guys to do is finish B and C, knowing how to do A. So you should have gotten 3.32 and 10.61 with the equivalent logs there for solving rounding using the hundredth spot. One of the last two examples that we're going to look at is ones with exponents that have more than just x in it. There's operations in here. And so we're going to do the same thing. Nothing changes. Log of 6 raised to the x plus 3 equals log of 50. Still take the logarithm of both sides. Now what you're going to do is take that x plus 3, since it's the power, and bring it out in front. X plus 3 in parentheses, log of 6 equals log of 50. Notice that since that's in parentheses, and this would be 2, we can divide by log of 6 due to the fact that we're multiplying the 2. And then, now that the x plus 3 is alone, you would subtract the minus 3 on the outside. That is what x equals. If you're going to round it to the nearest hundredth, you would get x to equal negative 0.82. Why don't you guys try B? It's a little more difficult, but try B and then I'll put the answer up. And so the answer you should have gotten here is to be 2 times the entire product of log 2 divided by log of 1.03 plus 5. And that does equal, I forgot to write this down, 56.9. Notice that you add the 5 right here to the entire quotient and then multiply by 2 to get rid of a divide by 2. We will finish up with A and B in class. Have a good day and see you in class.